In this example, we are going to go over this problem here where we're asked to find the centroid x bar and y bar in terms of a and b of the shape shown. So this shape is enclosed by this horizontal line, this vertical line, and the curve of x equals ky to the fourth. Before we can start this problem, first we need to figure out what is k. So k is some constant and we need to solve for k using what the problem has given us. So we see here that this curve goes through 2 points. It goes through the point 0, 0, and it goes through the point AB, and we can use those points to solve for k. So using x equals a and y equals b, we're going to plug that in. So we have x a equals k b to the fourth, which leads us to get k equals a over b to the fourth. Once we have that, we can then start solving our problem here. So I'm going to copy and paste this picture down here. I'm going to consider a teeny tiny rectangle here. The height of that rectangle is going to be y, and the width of that rectangle is going to be dx. So the area of that one rectangle is going to be y times dx. So dA, the area of that tiny rectangle, is y dx. If I want the area of this entire shape, A, that will be the sum of all the rectangles, teeny tiny rectangles. So that's going to be an integral from 0 to a of y dx. So in this case, I need to solve for y in terms of x. So remember, x is equal to a b over b to the fourth, y to the fourth. So y is going to be b to the fourth x over a all to the 1/4, or that's b x to the 1/4 over a to the 1/4. So the area A is going to be the integral from 0 to a of y, which is b x to the 1/4 over a to the 1/4 dx. We can take out that constant b over a to the 1/4, and then we have the integral from 0 to a of x to the 1/4 dx. Taking that integral, we're going to have b over a to the 1/4 times, let's write it this way here. So we're going to have x to the 5/4 times 4 divided by 5, evaluated from 0 to a. Plugging in a and 0, we can get the a, the area of that shape, is 4/5 times a times b. Thinking back to our notes, we had the equation for x bar is the integral of x dA divided by the integral dA, which on the bottom there is that area that we just solved for. So this right here is A. So we're going to have the integral of 0 to A of x times dA, which is y dx, divided by the area, which we just solved for, is 4/5 AB. So here we have the integral 0 to A of x. Y is going to be bx to the 1/4 over A to the 1/4 dx over 4/5 AB. I'm going to leave the integral there as an example for you to solve, but I will give you the answer. X bar is going to be 5/9 times A. The problem also asks us to solve for y bar. So when we solve for y bar, or when we solve for x bar, we use this vertical rectangle here. When we solve for y bar, we're going to use a horizontal rectangle. So I'm going to repaste my picture here and draw a tiny rectangle there. And the height of that rectangle is going to be dy. And if we think about the width of that rectangle, here from here to here, that distance is x. So the distance, or the width of that rectangle from here to here is going to be a minus x, because the total distance from here to here is a. So the width of our rectangle is a minus x, and the height of our rectangle is dy. So we're going to have y bar is equal to the integral from 0 to b of y dA divided by our total area. So that's just the equation that we have from our notes. This is going to be equal to 0 to b of y times dA, which dA is going to be the width of that rectangle, a minus x, times the height of that rectangle, dy. And that's all divided by our area, which we've already solved for. So here we have the integral 0 to b y times a minus, we can use our equation for x, is a over b to the 4th y to the 4th dy divided by our total area A. I'm going to leave the integral for you to solve and write the answer is y bar is equal to 5 divided by 12 times b. So that was an example of solving for the centroid, x bar and y bar of an area using the integral.